A metric is not reality. It's a lossy measurement with assumptions baked in. There, I said it, I'll own it. But when we talk about observability, what really is a metric? Let's find out. Hi, I'm Jack Neely, and I'm an independent observability architect and owner of Cardinality Cloud, LLC, where observability is leverage, not tax. Today, what really are metrics? In common English, metric refers to a standard of measurement. That definitely applies here. But where people often get confused is thinking that a metric is any numerical measurement, or really just any number. This isn't correct. In observability, a metric refers to a specific data type. Remember your computer science? Arrays, linked lists, binary trees, and hash tables are all specific data types. Implementations may vary, but each data type has specific strengths and weaknesses. Each data type is really efficient at solving some problems, but not others. Metrics are pre-computed summaries or aggregations, sampled over time, usually every 15 seconds, or 30 or 60 seconds. Not raw events, which means they're lossy. For example, we might track CPU usage or RAM usage over time. We would keep a running count of API requests that we returned successfully or that we returned with an error. We can also track how long that API call took with an average or a histogram. This is fundamentally different from logs and traces, which are raw events with full context, such as the user and the exact error message, which show the flow of events through your system. Metrics trade detail for efficiency. In the time series database, or TSDB, where metrics are stored, a metric's name is converted to a label. All of these key value style labels are used to create a unique ID for this metric. So if any one label changes, bam, new metric. Next, for a new metric, the TSDB allocates an array and tracks the next free index that hasn't been filled yet. Each index holds a timestamp, an unsigned 64-bit integer hopefully, and a measurement value usually in a float 64. Each time a metric sample comes in, it is mapped to the correct array, and the timestamp associated, usually right now, as well as the value are stored in the index location. The index is incremented for the next sample. With modern compression techniques, it's not hard to achieve, on average, 1.5 bytes per sample. This makes storing metrics incredibly efficient and cheap. Selecting subranges of these arrays is also a cheap operation, making queries fast and effective. Graphs become plentiful. I think of good metrics as being able to build an intentional model of a complex system. A model here is a simplified, abstract representation of a system that explains observations and makes predictions. Think about how Newton's laws of motion were able to build a model of planetary movement in our solar system. A common saying, all models are wrong, but some are useful. Einstein later improved our model of the solar system and corrected details that Newton could not account for. This is how our understanding of a complex system grows and matures over time. The downsides. What are the weak points of using metrics? Well, number one is that you cannot extract a single raw event or sample from the collected metrics. While you can generate a P99 percentile of latency around a given point in time, you cannot recover the exact latency of a specific user's request. Another big point to know about metrics is avoiding cardinality explosions. Look again at the data type. The memory or space complexity, big O, is n squared. The number of metrics in the system maps to an exponential increase in memory requirements. Yikes! This is usually kept in check by a relatively constant set of active metrics. A cardinality explosion happens, and there are more possible unique metrics. Think about those key value style labels, than data samples. This leads to a sparse matrix in the TSDB's memory, where a metric only contains one or two data points. Suddenly, things become very expensive and very inefficient. Let's wrap up. A metric is most definitely not any number you can squeeze out of your observability platform. It is a specific data type with strengths and weaknesses. It is one of many options we have available to us in observability. Remember Newton and Einstein. Metrics build models of complex systems. Do you need help building models of your complex distributed system? That's what I do. Link in the description.